Right, today we're taking a look at lesson 7.5. Just a little more with proportions and similar triangles. There's a little bit of a different look to these, but you're going to see real quick here that the math here is extremely similar to what we've already been doing. So what they're telling us within this first example is that this triangle is similar to this triangle. Right, so again, they're proportional. So all we have to do is to solve for x, which is this guy, is simply match up their corresponding parts and set up a proportion. What they're telling you with this rule is when you match up their corresponding parts, you're allowed to use things like an angle bisector. So remember, we dealt with this a lot during semester 1, but because this angle is congruent to this angle, that makes BD an angle bisector. Right? It cut angle B into two equal parts. And so just like I can use these outside numbers within my proportion, I'm also allowed to use these inside numbers that relate to the angle bisector that you're seeing. So I'm allowed to say something like 24 over x is equal to 10 over 8. So real simple. It's again not much different than what we've already been doing within these. So let me go through a couple examples here to make sure we're good to go. So on this one, again, we can see that 9 is the angle bisector of this triangle, 6 is the angle bisector of the little triangle, and because we have similar triangles, then I'm allowed to set up my proportion here. So again, guys, the whole point of this is consistency, right? As long as you're consistent in the way you set this up, you should be safe. So if I'm going to do 12 over x as my first ratio, then I have to do 9 over 6 as my second ratio. So that's one good way of setting it up. You could even work this way with it if you wanted to. I can say 12 over 9 equals x over 6. So again, as long as I'm consistent in the way that I'm setting these up, I should get the same answer no matter which way I do it. Guys, I know you can cross multiply from here. Again, you would do 12 times 6 is equal to x times 9. So what would that be? 12 times 6 is equal to x times 9. And then, of course, we just divide both sides by 9 to get our value for x. So here's another one if you want to pause and try one on your own. So as I look at these, again, just being consistent in the way that I set these up, I know I'll be safe. So if I want to do left over right, so 4 over 3, then I can use this guy over this guy, 3 over x. What the special segments that they are using in this section was they actually come from one of the chapters that we never got to, which I believe was chapter 5, because we ran so short on time this year with our limited number of days. Angle bisectors you guys already know. This one we haven't talked about yet this year, but I know you've heard this word. Whenever you go from the top of a triangle straight down to the base, we call that the altitude. So that would be the altitude of that triangle. Not that big of a deal because the same rules that we've been using all chapters still apply, right? Consistency in the way that you're setting up your proportion. So again, same thing over here. This would also be considered an altitude because it starts at the peak and it goes perpendicular to the base. So even on something like this, we could, again, set up our proportion. I could do something like x over 7 is equal to, and I could use 10 over 8. And then we could obviously solve for x from there. The one last one I'll mention here is a segment bisector. Now we've talked about bisecting segments already, and we've even talked about segment bisectors in the past, so this one won't be a whole lot new either. But whenever you go from a vertex to the midpoint of the opposite side, we have what we call a segment bisector. Again, not that big a deal other than, let me just fill in what we should obviously recognize here. Just be consistent in the way that we set up our proportions on this. So if I want to compare something from the top triangle to something on the bottom triangle, such as their segment bisectors like 12 and 14, then I could compare something from their bases like 12 and x. And there's a nice easy one to figure out. So obviously 14 is going to be our value for x on that one. Let me flip over to second page, last page. Something called the triangle bisector theorem, triangle angle bisector theorem. The difference in this one is now you are only dealing with one triangle instead of two. All the examples that we just did on the previous page, you were comparing things from two different triangles. This one is unique because we're setting up a proportion within one triangle. So CSRT is just one big triangle. So that's why they call this the triangle angle bisector theorem. I can see that this is an angle bisector because that angle is congruent to that angle. So that makes SU an angle bisector. So real simple, the way that we set this up is just with a proportion. We could say something like 15 over x equals 30 over 20. Consistency is the key, right? So I can do left over right. I could do 15 over 30 equals x over 20. And that works too. So as long as you're consistent in the way that you set this up, just like all the other ones, you should be safe. So I'll go through just a couple things with you real quick and we'll be good. So again, let me kind of quiz you the same way I did on in an earlier lesson. If I set up my first ratio as 25 over 20, how would I have to set up my second ratio? So if I did top over bottom on the first one, then I got to do top over bottom on the second one. And then I know you guys can cross multiply from there. I'm trying to pick out ones that might look a little different to you. Let's look at 3 and 4 because they're a little bit different. Number 2 is just pretty darn identical to the one we just did. So let me jump down to this one. So this one's a little tricky because they're not telling us what this is, right? All they're telling us is that this entire length is 46.8. So how do we identify an expression for that piece right there? Well, let's just say I told you guys that this was 10. Well, what would that have to be? Or how would you get it? Well, if the whole thing is 46.8, all you would have to do is subtract 10 from that to figure out what this was, right? So by taking the whole thing and subtracting out this guy, that tells you what this length is over here. So what we can do is say, well, the whole thing is 46.8. So if I subtract this guy, then that now gives me an expression for that segment right there. And now I can set up a proportion using the rules that we did up above. I could say something like 36 over this. So I did bottom over top. So on the other side, I need to do bottom over top, 42 over n. And I'm right back to cross multiplying. So not too bad, but that little extra step, here's a much easier version of that problem. So take a look at this one. If the whole thing is 15, and that much of it is 10, what does that leave you with for this guy right here? So if we use that same subtraction idea, I can identify this as 5. And this one's much simpler because it doesn't involve n or a letter. But now I can set up my proportion like x over 10 and 13 over 5. Alrighty. And then the one down here, number 6, is just already very similar to ones that we've already done. I'll do it if you want to give it a try for practice. You can pause the video and I'll follow behind you. So I'm going to say x over x plus 7. So if I were to do this over this, then I got to do 11 over 17 as my other ratio. And again, more than one way that you could have set this up. If we do it correctly, we should still get the same answer. So if I cross multiply, I'm going to start with x times 17. And then I'm going to do 11 times x plus 7. Don't forget the parentheses, because we do need to distribute. So that would give me 11x plus 77. And then if I subtract 11x from both sides, and we're not going to get a very pretty answer on this, but that's okay. I'm just going to leave it as a fraction. So if I divide both sides by 6, I get that right there. And that is it for 7.5.